All right, the long leg of a right triangle is 7 feet longer than the short leg. Okay. A quick reminder, because they say it's a hypotenuse. That's important too. And then they said their legs. We're looking at a right triangle here. I think I can get one with the technology. So here's my right triangle, which is pretty because I use technology. That's a right angle mark that I just put in the bottom left there. The two sides that make up the right angle are legs. So there's a leg in red and there's a leg in purple. My green side for me is what they call the hypotenuse. Key and Peele did a decent skit on it. So if you like it, go watch it. But in all the most unlikely places, we have found Pythagoras once again. But he did choke out a dude for questioning him on things, and it didn't turn out very pretty. He killed him. Also, he ended up having a lot more power than you'd want probably one person to have. In any case, we have the long leg of a right triangle. I don't really care that it's longer, but we see that it's 7 feet longer than the short leg. That's kind of crucial. So what I'm going to do is I'm going to formulate a variable here myself. I'm going to make it x. You can make it whatever you want, but I'm going to use x. I'm going to say that's the length of the short side, the short leg. And I guess since I'm doing it in red, this will be my short leg in red, even though it appears to be longer than the purple one. Okay, so the purple one will be my long leg then, and it is related to the short leg. So you could take the short leg, but it's 7 feet longer than that. So that's my longer leg right there. Then it said, in addition to that, the hypotenuse is just a straight 13 feet, looks like. Well, I made this colorful and it's pretty, but we got to go back to the Pythagorean theorem, okay? Now I'm going to do this, well, I'm going to do it a little bit different, okay? So you take, yeah, you can use the abstract on this one. Yeah. I'm going to show it a little bit different, just related to the words that they're using. Oh, hypotenuse. Okay, so we got two legs and a hypotenuse because it's a triangle. If you were to square the legs and then add them together, you'd get the same thing as the hypotenuse as a square. And when we say squaring, we're literally talking about if you were to make squares out of those side lengths, the area of the two legs as squares would be the same area as the hypotenuse as a square. Okay, so we have the values though. I know the hypotenuse is 13. Uh-oh. Technology. My first leg in red, just x. And then my longer leg in purple was x plus 7. Okay, so again, applying the Pythagorean theorem, I really don't need parentheses around that first x, just x squared. But the longer leg, I do need the squared on that one. And then the hypotenuse also is a square. So we can see that this is setting up, it will set up eventually to be a trinomial. We just got to get to that point, okay? And we need it to equal 0, just like we've been doing. So on this one, I'm going to show x plus 7. So I'm going to show probably more work than you want me to do, but I'm still going to do it. Okay, so that's x plus 7 to the power of 2. It's x plus 7 times x plus 7. And then some distribution, or FOIL, gives me x squared plus the 7x's. And then more distribution plus another 7x plus 7 times 7 is 49. Okay, now I still got the other x squared. And I do need all this stuff, by the way. And this equals, I'll evaluate 13 to the power of 2 right now in the calculator, 169. Okay, so that is, it's the distribution part of this. Now that we've done distribution, we're going to look to combine any like terms. I've got x squareds. How many of them? 2. 1, 2 of them. And then I've got x's, which I can combine. How many x's? 7 plus 7 is 14. Then I still got the plus 49. And this equals 169. Which is 120. So yeah, now we're going to force that to become equal to 0. So minus 169. Minus 169. So that's going to be a negative 20 right there. Equals 0. Oh, thank you. That would have been disastrous. But we got it, so 2x squared plus 14x minus 120. Sorry, that's kind of an ugly 120, but I did jack it up. Okay, now at this point, we have a trinomial equal to 0, which is what we want, but I also see that I have a leading coefficient of 2. 14 is even and 120 is even, so I'm going to factor out that 2, okay? I'm going to factor out a 2. The first term is going to leave me with just the x squared. 14 divided by 2 is 7. That's how many x's I got. And then negative 120 divided by 2 is going to be negative 60. This should still equal 0, which it does. Now, in factoring this, I don't really care about the 2. I'm going to skip this. So the last problem, I kind of got rid of it like the negative 16, right? I'm going to keep it this time just to show you that you can. And we're going to factor this trinomial into 2 binomials, okay? So everything else stays the same. I know I'm going to have x's as my first term in both binomials, but I need 2 factors of negative 60 to add up to 7, 3, 15, 12, and thank you. Is it positive 12 and negative 5? Thank you. So that's plus 12 and negative 5. Remember, I'm not using factoring by grouping here because I'm taking that shortcut that we saw in, what was it, 4.3, thank you, maybe 4, somewhere in there. Now again, if I just need these 2 factors to equal 0, which is why the 2 does not matter. And so in solving these, if I can get x plus 12 to equal 0, that'd be good. So I'd subtract 12 from both sides and get x equals negative 12. Okay, now, okay, so x is negative 12. I'm going to leave it at that, but I'm going to come back to it, okay? If I can get x minus 5 to equal 0, then I would get a true statement here on this equation, which should be the other one as well, but adding 5 to both sides means x should equal 5. Now, just like the last problem with the rocket, here it's saying that x is negative 12. Now, if you say x is negative 12, that means we have a negative length. We should not have negative lengths. So that means that this one is invalid right off the bat. Would it make this equation true? It would. It doesn't help me because I don't want a negative length on a triangle. I don't even know how you'd make that look.
Inverted.
You could take the absolute value, but in any case, let's go back. Okay, so it says how long are the legs of the triangle? Well, I know the short leg is just x. So this 5 right here, that is the short leg. By the way, it's not just 5. It's 5 feet, yep. Don't forget to label these because on a test, I feel bad. But that's my short leg, okay? So and if the short leg is 5, we know the long one is just 7 more than that. So the long one would have been 5 plus 7, which would have been 12 feet. Now these two should work. If they do work, then 5 squared plus 12 squared is 13 squared. It is. You'd have 25 plus 144, which is 169. It works. So that's my 2 answers right there. You'll notice that the negative was negative 12, which is kind of told us what the other value was. But we just make sure you put it back in. Make sure it actually is 7 more than the shorter leg if you set it up like this.